If you've done the investigation at the back of the book and the reading at the top of the page here, you will have discovered something very important. It's only possible to make an Eulerian circuit if the degree of each vertice of a network is even. That helps us solve the Konigsberg bridge problem, which was posed back at the start of this chapter. Now, Euler posed the Konigsberg bridge problem originally, and the question was, in his city of Konigsberg, is it possible to make a walk around the city crossing each bridge just once? You can get the map of the city and transfer it to the network graph, and just remember when you do it, it's actually the bridges here which are forming our edges, and the land masses in between which form the vertexes. Now, is it possible? Well, if you look at that network, you'd have to say no, because we're talking about an Eulerian circuit here. We're talking about travelling over each of the edges just once, and getting back to the same place that we started with. Now, that's only possible if the degree of each vertex is even. And if you look at this, we've got vertexes here of degree 3, 5, 3 and 3. In fact, all of them are of odd degree, so certainly not possible. So, an Eulerian circuit, which we're trying to do, only possible if all the vertices and here in fact we've got them all odd. Would it be possible to tour the Konigsberg bridges crossing each just once but completing the tour in a different point to where we started? Why or why not? Well, once again here you'd have to say it's not possible. What we're talking about here, starting at a different point to we finished with, is making an Eulerian path rather than an Eulerian circuit. Now, Eulerian path is possible if just exactly 2 of the vertices are of odd degree, and when we said we had 4 of them of odd degree. So and the last question is, if you could destroy just one bridge to make the tour work, which one would you choose? Well, I don't think it would be possible to create an Eulerian circuit by destroying one bridge. But if you were to destroy the bridge AB, then we would have B would be of even degree, A would be of even degree, C and D would still be of odd degree, but then you'd have exactly 2 vertices of odd degree, so that would mean you should be able to do it as an Eulerian path. And in fact, starting at C, you will go C, A, D, maybe back to C and round here to D, and you would have done the tour starting and finishing at a different point. So if bridge AB was destroyed, then it So starting from C, A, D, back over to C via A, and round to D. That would do. At the bottom of the page here we've got some network graphs, and we have to decide whether or not an Eulerian circuit or Eulerian path is possible. Now, with the first one there, if you look at the degree of each vertex, it's degree 2, degree 4, 4, degree 4, 4, 4 and 2. They're all of even degree, so that should mean that an Eulerian circuit is possible. How would you do it? Well, starting from A, if you went around the outside to F, and then went G, E, C, G, B, F, A, you could do it. Okay, it's going to be quite long. G, E, C, G, B, F, A. We got there in the end. What about the next one? Check out the degree of each vertex and see if they're all even. Degree 2, 4, 2, 4 and 4. So an Eulerian circuit should be possible. So starting from A we could go to B, maybe down here to D, back to B, C, D and A. That would do it. But this last one, what's the degree of each vertex? 2, 2, 4, all even, but this one and this one are of odd degree. That means that you can't do an Eulerian circuit, but it would be possible to do an Eulerian path. In which case it should start at one of the odd vertexes and finish at the other. So starting at C we should be able to do it. C, D, E, C, B, E, A, B would be okay. C, D, E, C, B, E, A, B.